Okay, now because the properties of similar triangles. Okay, now because the properties of similar triangles for any given angle, for example, we used a 65-degree angle in the last segment, any of the ratios of y over r and x over r and y over x will have the same value for any point on the terminal side. To exaggerate that, I just see this picture I have right here. I could have drawn this triangle. So I'm going to exaggerate, and your triangle might have been drawn larger. But no matter what, the right triangle here and the right triangle here, the ratios of y over r for what's called the sine of theta, so the ratio of this y over this r would be the same as the ratio, let's call it y prime for this long side and this large hypotenuse, which would be called r prime, if you will. Those ratios would be the same. So we did some measuring in the last segment, and you'll do that in your project as well. So we've established there's 6 different ratios that you can do in any given triangle. I'm going to go ahead and delete all that y prime, and there we go. All right, so the sine of an angle theta is going to be defined as the side y over the side r. We also, for this particular angle, would call this side the side opposite that angle theta. So please know that for this angle, this is also called the side opposite. The side called x is horizontal or parallel to its own axis, but it is often called the side adjacent when we're speaking about, here's the angle we're talking, say it was 65 degrees. This side is adjacent to this angle because this side right here already has a name. It is always the hypotenuse because these trig functions are based on right triangles. So this always has a name, hypotenuse. The side that forms the angle that we're speaking about, this theta, is the adjacent side, and then this is the side opposite that angle. If we were talking about this angle up here, beta, then this side would be opposite, and this side would be adjacent. Don't want to go there yet. I want to mostly think in terms of x, y's, and r's, and let's just stay there for right now. So the sine of theta, sine in its long form is spelled like this, cosine is spelled like this, and tangent is spelled like that. But we use the abbreviated form that you see on your calculator. This one, would you notice this y over r? Do you see this r over y? These are called the reciprocal functions of the main reciprocal. There we go. So this one is called cosecant. This one is called secant, so I'm writing out the longhand name of it. And this one is called cotangent. Not used quite as often until we get into our calculus work, but we will do a little bit with this. You'll notice your graphing calculator has sine, cosine, and tangent. Those are the 3 trig functions we will use to solve the stories, the applications of this. All right. Just remember that the Pythagorean Theorem is going to apply because we're working with right triangles. And we're going to go ahead and draw a few triangles now in where the terminal side is through this ordered pair, and so 5, 12 is the ordered pair we're going to draw this through. So I'm going to go over here 1, 2, 3, 4, 5 units, and then I go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units. So I'm going to put my ordered pair right there. If I drew those well, then I have a pretty good depiction of the size of angle that I have right here. So I was trying to draw it to scale, where this side is 5 and this side is 12 in this right triangle. I'm asking you to just find the values of the trig functions. What I mean is the fractions. So finding the values of the trig functions, if I want to know the sine of theta here, then I want to know what side y is divided by side r. Well, I gave you x in the ordered pair. I gave you y in this ordered pair. You have to use the Pythagorean Theorem or your program that you've written to discover that the hypotenuse is equal to 13 in this right triangle. So finally, to tell me the ratio, the fraction of y over r, you just have to give me the 12 for the y and the 13 for the r, y over r. For the cosine of theta, you just have to give me the x value divided by the r value in this picture. So for this angle theta, my x value is 5, my r value is 13. I just need to put in 5 over 13. Finally, the tangent is defined as y divided by x. In this picture, y is 12, x is 5. So I have 12 divided by 5. Remember that these trig functions over here, a little bit less used, called cosecant, secant, and cotangent, are just flips of these fractions. So see this 12 over 13? I'm just going to come on over here and write this as 13 over 12. See the 5 over 13? I'm going to write this as 13 over 5. 12 over 5, I'm going to write this 5 over 12. Those are the 6 ways that I can write ratios for any given right triangle that has 3 sides. Excuse me, one last thing that I'd like to share with you. Guess for a minute what the size of that angle is right there, just based on my drawing this picture possibly accurately. I'm going to guess that theta is between 68 and 72 degrees or so. Now remember, no matter how I draw the size of this triangle, it could have been right here, the perpendicular, it could have been here, it could have drawn it out further. The ratio of 12 over 13 belongs to just one particular angle. The way you go find out which angle that is you take your calculator and you go, I'm sorry, this is a little tiny. How could I maybe, I'm going to try to expand this just a little bit. So in order to find out the size of this angle, when you know this ratio, do you see the sine to the -1 there? You go second sine, and you tell the calculator that the ratio of the y value divided by the r value is 12 over 13, and it'll go in and tell you, it's got a big old memory bank full of tables of data, and it's going to tell you that that angle was 67.38 degrees. So remember, I guessed that it was between 68 and 72, and I truly didn't look at my notes. Actually, it's not even written in my notes. But I want you to see that with a ratio like that, we're talking about that size of an angle. If I happen to just know cosine was 5/13, I could go second cosine of 5 divided by 13. Whatever you do, when I type on the calculator, you should pause and practice the same thing to see if you can get it. If you've not used this graphing calculator before, you really need to practice this with me as well. Well, that was supposed to give me the same angle. It's just that it's a different definition. It's the ratio of the side x over r, and so is tangent supposed to give me the same answer. So the inverse tangent, if I only know y and x, I could find out that that was a 67.38 degree angle. So any one of these ratios would give me the size of that angle that I kind of guessed was between 68 and 72 degrees. And this is where I'm heading with this. Again, please just notice there's an angle and there's 2 sides in any one of these definitions. If I know 2 pieces of information, like this one and this one, I can find that one. Or if I know those 2, I can find that. Or if I know these 2, I can find that. Because in algebra, if you have 2 pieces out of these 3, you can solve for that third. It's probably not a good general statement, but it's in this trigonometry, it's not a bad statement at all. I'm going to go ahead and illustrate not this one. I'm going to skip to the next page, and I'm going to illustrate this one because it's a little bit more unusual. So if you have a right triangle where your x value is a square root of 3, which I just need you to know is 1.7-ish, and your y value is 2. So I'm going to go over 1.7 and up 2. So I'm just going to draw this right triangle. So here's theta. This is 1. I'm actually going to replace that with not 1.7, but I'm going to call it the square root of 3. This is 2. By your program, your Pythagorean Theorem program, when you put in the square root of 3 for one of the legs and 2 for the other leg, the square root of 3 squared is 3. And 2 squared is 4. So that's the square root of 7. But your calculator is going to give you that the square root of 7 is 2.65. I just want you to know that our text is going to leave that as a square root of 7. It's not going to call that 2.65. I don't care which way you give it to me, but I just need you to know that's what the text will do. Remember, sine is defined as y over r. Our y value in this problem is 2. Our r value is square root of 7. I'm going to come back to that in a minute. Cosine is defined as x over r. Our x value is the square root of 3. It's right here on the x-axis. Our r value is the square root of 7. So square root of 3 over the square root of 7. And then finally, tangent is defined as y divided by x. Our y value is 2, and our x value is the square root of 3. Last thing I need you to know. Most math people don't like to leave radicals in their basement. It's a silly thing. It's like not wanting, asking you to reduce the fraction 2/4 to 1/2, which is not actually all that silly. And what we do is we rationalize the denominator to do that. So to get rid of the radical downstairs, we will multiply top and bottom of this fraction by the square root of 7. That's because this is equal to the number 1. The same thing divided by the same thing is the number 1. So the answer you will find in the back of the book for this problem is 2 times the square root of 7 in the numerator, and then the square root of 7 times the square root of 7 is the square root of 49, which is just 7. And now you do not have a radical in your basement. Same thing would happen right here. You'd multiply top and bottom by the square root of 7, and so upstairs, square root of 3 times the square root of 7 is the square root of 21, and downstairs square root of 7 times square root of 7 is 7. And again, finally right here, you'd multiply top and bottom by the square root of 3, so upstairs you'd have 2 times the square root of 3, and downstairs the square root of 9 is just 3. You should write the reciprocal functions over here, but in an effort to save